10 minutes. Power can be supplied by the source and then dissipated by each one of the resistors. Okay?
So there's a couple of things that we need to remember about power to get power in a series circuit. And the first one is that P equals VI, right? This is our usual power formula, but we can also do this with totals, right? Power, power total equals the voltage total times the current total, right? So if we look here and we remember that in a series circuit, V total is going to equal, V1 plus V2 plus V3. So, but the voltage total here is just going to be the 6 volts. When we talk about V1, we're just talking about what the voltage drop is going to be for each of these, right? So we're not super concerned about the voltage drop here, here, or here at 1, 2, or 3, right? Because this 1 stands for this one, this 2 stands for this resistor, and this 3 stands for this third resistor, okay? So what we're concerned with is the voltage total, which is going to be 6 volts, okay? So we have this, right? We have this part of our equation. We have the voltage total. What we need really is the current total. And the current total is going to look a little bit different, right? For a series circuit. It's going to be I1 equals I2 equals I3. So we know it's going to stay the same throughout the whole circuit, right? But what we really need to do is we really need to use Ohm's law, not this one, right? Not the power formula. This is the power formula. But we need to use the Ohm's law formula, right? Which is V equals IR, right? And again, we can put that applies to totals for the whole circuit as well. So what we can, using this and using our circle, we can get this I that we need over here to calculate the power total, right? So what we're going to do is we're going to put V, I, and R, right? And what do we got? We got 6 volts, right? And then what's our total resistance? So we got 4, 11, and 13. So we're going to add all those together, which equals 28, right? We got 28 ohms of resistance. So we know this is going to be 28 ohms, right? And that will go here, right? So 6 divided by 28, real quick calculation of that. 0.214 is going to be I, right? 0.214. This is 6, right? And that's going to be in amps, right? And this is going to be I total. So now we can plug in that 0.214 there. I'm going to move my head around a little bit over here. Let's put me up here for the time being. This calculator, I got to move this calculator. Hopefully you should have this in your notes, right? And if you don't have this in your notes, let's go back and do this again with your notes. Okay. So now that we got V, right, which is our 6 for V total, right here, right, that we can put in there. So we got power total equals 6 volts times I total, which is this 0.214 amps. 0.214 amps, right? And we may or may not calculate the power for each resistor, right? There's a different power here, there's a different wattage here, there's a different wattage here, and there's a different wattage here. Now, I haven't decided if we're going to go that deep into this material yet or not. It'll definitely be after the quiz that you're going to see at the end of week 4 here, but I'll make that determination in the next couple of days of week 5. We're going to calculate power for each one of these. But for right now, we're just worried about the power in the total circuit. Right? This is power total. And that's why we're using voltage total and current total. Okay? So let's say 6 times 0.214. That's going to give us power total of 1.284 watts. Okay? That's going to be my final answer for the power total of a series circuit, right? So what I'm going to do is I'm going to work through one more. Right, so here's example number 2, right? And again, we're going for power total equals voltage total times current total, okay? So let's start out by saying, okay, we already know one of these. Our voltage total is 4.5. Pretty easy, right? So step number 1 is get voltage total. That's super simple, just the battery, right? Just the battery voltage. Don't have to do anything complicated for that. Number 2, we got to get I total, right? Sorry. We got to get I total. That's a little more complicated because we have to use V total equals I total, R total. And we have to use our circle, right? And again, this is V, I, and R, right? And so we're going to add up our resistance, our R. 10, 11, and 12. We got 22, 33. And we got 4.5. Right, because the V goes on top. That's where we got our V. The total resistance, R total, is going to go here, right? Because this is R total. And our I is going to go here. And that just gives us 4.5 divided by 33. Okay. Let me pull out our calculator, clear that out. And we got 4.5 divided by 33. So I total is going to equal 0.136. Okay? So now that we got voltage total and we got current total, which is 0.136, and that's going to be amps, right? Amps here. We can do power total equals 4.5 times 0.136. 4.5 times 0.136. Not a super complicated idea, right? And again, power is always going to be in watts or W. One really easy step. One step's a little more complicated. We have to get I total, and again, we're going to use Ohm's law formula for that. V equals IR, all totals. And again, P equals V times I total, all totals, right? And shouldn't be too rough for you, I'm hoping. By all means, you can always give me a call or send me a text if you have some questions about this. 0285 is my number, and we can get you helped out. We can get you sorted. Okay. Thanks so much. Best of luck with these questions.
Okay, did you understand? Well, maybe I can be a little bit more clear. Okay. Okay. Are you looking at the PowerPoint presentation?
Yes.
Are you
Yeah.
watching this? Okay. Let me put this in complete screen. This exercise, we made it yesterday, remember? Just calculate the total resistance and then calculate the voltage drop across the second resistor. As we calculated the source, because the total is 25, 50 over 25 is 2 amps. Then the voltage is the current, 2 amps, times the resistor, that is 4 ohms. 2 times 4 is 8 volts. That's the voltage drop. Then we can continue and calculate all the others, but that's not what is requested in the exam. Okay, let's raise. Okay, that's the power distribution in a series circuit. The power applied by the DC supply must equal that dissipated by the resistive elements. That is, if it's like the voltage, you have a voltage and it is dropped across all the resistance, and the sum of all the drops must equal to the total voltage. The same thing is for power. The power applied must be equal to that dissipated by each one of the resistors. It's easier to see in this diagram. This is a big power. You can see by the width of this line. This is uh, supplied to each one of the resistors, and it will be uh, split, dividida, como sea, se va a repartir entre las tres resistencias. La potencia total de la fuente, que es PE, porque es de Electromotive Force, la, la, la potencia de la fuente. Aquí es la potencia disipada en la resistencia 1, la potencia disipada en la resistencia 2 y la potencia disipada en la resistencia 3. ¿Ok? Y deben de ser iguales. The power of the source will be equal to the sum of the power of each one of the resistors. This is for series, but later we will see that in the case of parallel circuits is also the same. The power will be the same even they are not in series. But in this case, in series, uh, no complication. Now we can have here the first, remember from the video, the voltage, that's the source, times the current, that's the power. And that's the power. We can calculate it here. We can calculate it here. We will put V instead of E, because E we use for the power supply, and we will use here V1, V2, and V3, the voltage drops across each resistor. And then we will have another two forms. This arrow is for this. This formula is the same formula. And as in the video, they're calling I1, I2, and 3. But actually, we are going to have only one I. We will have only one IS. Okay, the same is passing here and passing here, so we don't have to call it I1, I2, or R3. We just call it is, or simply I, or as in the video says, you can say I total. But there is nonsense to say I total also, because there is only one current. You don't have to totalize anything. Okay? But these two are two new equations. Please take note of this equation. Your notebooks, please take note of this formula, because you will need it for your formulary in the exam time. Okay? If you know the voltage and the current, you just calculate using voltage times the current. If you know the current and the resistance, you can put the I to the square and multiply by R. But if you don't know the current, but you know the voltage, you can put the voltage to the square divided by R1. How do we come to this? Okay, we have this is the original equation. But we can, by Ohm's law, we can substitute in the first case B, B equal RI. We can substitute here R I, because I put it here, understand it. Me pierde, acá está. You remember by Ohm's law, RI. Then we substitute this value here, and this will be R E squared, I-E times E. So this is R I squared and comes to here. You know how it comes from this simple formula? We replace, in this case, we replace the current. In this other case, we can substitute here the voltage. We can see here that I forgot how to do this. It's very simple, but you have to put here. Actually, we'll say here VI. This is VI. Okay. I will replace the I, and I will put here V here. But in this case, I will replace this I. I equals B divided by R. So I replace it here, and we'll have B, forget about the number 1, 4 times times V divided by R. Okay, so this B and B is B squared divided by R. That's what that's the way we obtain these two equations, this and this. So we will have three equations. I will erase all this so you can see the clear picture. Okay, I need to erase this also. I cannot erase this. Okay, well, let's do some examples. In a series configuration, the maximum power is delivered to the largest resistor. Of course, in this case, we can assume here, we can see that this has a bigger power, then for sure this R2 is bigger than this and this. This is bigger, then follows this, and this is the lower resistor. So it consumes less power because it is in function of the value of the resistor. Bueno, aquí esto ya no lo puedo borrar porque ya se me quedó en la presentación. Bueno, para el circuito de serie de la siguiente figura, we have 36 volts as power supply, voltage supply or battery. Uh, this is the value, these are the values of the resistors. Then we will have a current in this direction because this is the positive side, goes from plus to the minus sign. And this current will produce a voltage drop at each resistor. Okay? Then we will have to obtain the value of the current because we don't know. So first we will have to obtain the total resistance. Once we obtain the total resistance, we put it here, our total, and will be divided by this voltage on the total resistor. But let's do it step by step. Total resistor, here is the solution. There are only three resistors. 1 plus 3, 4. Plus 4 is 6. 6 kilo ohms. We are not converting to ohms because they are all kilos. All three are kilo ohms. Well, we will sum kilo ohms with kilo ohms. We are not mixing kilo ohms with ohms. So we obtain that we will put here. Then calculate the current. You know how to calculate the current, you know? You have to divide this voltage over the total resistance that you just calculated will be 36 volts divided by 6 kilo ohms. You know, it's like we cancel this and this B over R. Aquí tenemos el valor de la corriente. And because we are using kilo ohms, we could convert this to 6,000 ohms and obtain 0.006 amps. But as a rule, not written rule, but you can assume that if you are working with kilo ohms, the current you will obtain will be in milliamperes. So once you know the current, and because it's the same current across all the resistors, we can obtain the value of the voltage. For the voltage, we cancel the letter B, and it will be I times R. So it will be 6 milliamperes times 1 kilo ohm. It will be 6 volts, and this will be the triple, and this will be the double, because we multiply the same quantity times 1 kilo ohm, 3 kilo ohms, and 2 kilo ohms. And because we are using kilo ohms and milliamperes, we will obtain volts. Okay? 6 milliamperes times, we obtain millis and kilos. Let's say they cancel, and we obtain the volts. 6 volts, 6 times 3 is 18 volts, 6 times 2 is 12 volts. Okay? I cancel this because it says I1, I2, and I3, and that's not the case. We only have one current, that is IS. So don't worry about this, and keep this is the only one current. Then we have to check that the total voltage here, the voltage drops, will be equal to 36. Okay? 18 plus 12, how much is it? 2, 10, 1, 2, 3. 30. And 6, 36. Okay, 36 is correct. Don't forget to check up. Then the power supply to the battery. There's another uh, uh, is the with the first formula we use is in this, we will have 36 times 0.006. Let's see. Power supply. Okay, we have here this formula, 36 times 6 milliamperes. If we apply this directly, we obtain the power in milliwatts, because we are using milliamperes. Oh, actually is 6 times 10 to the minus 3, and we obtain 0.216 times to the minus 3. That would be also milliwatts. And determine the power dissipated by each resistor. Oh, we will have to use this. In this case, we will have as a data, we have the current, we have the voltage of every resistor here, and we have the general formula, that is this one. So this is the power supply. I put it here, and we are going to determine the dissipated power at each resistor. Okay? Notice that in the first case, we are using this formula. 6 times 6 is 36 milliwatts. Milliwatts because these are milliamperes. In the second case, we could use the same formula because we could see 18 volts times 6. 18 por 6, ¿cuánto da? Pues debe dar 108. Podemos haber usado esta misma fórmula, Pero para ejemplificar, vamos a usar esta otra fórmula, la de I cuadrada por R2 en este caso. So 6 to the square times 3. 6 to the square is 36 times 3 will come out with 108 milliwatts. And in the third case, we are using the third formula, that is the V squared divided by R. So we have here the voltage drop V3 is 12 volts. We put it here and elevate to the square and divide by the resistor, which is 2 kilo ohms. Okay. Okay. And the result is 12 by 12. 12 times 12 is 144. Divided by 2 is 72. So this is the power dissipated across each resistor. And we have to verify, make the addition, 108 más 66 va a ser 124 y 72. Debe ser, seguro que va a dar los 216. ¿Okay? Aquí nada más es verificar que efectivamente estén utilizando verificar que esta suma, verify that the power supplied by the source is equal to the sum of all the three power dissipated at each resistor, power 1, power 2, and power 3. Okay, we have just done this, and this is the formula here, and the solution is here. For me, I can see this complete because I have a message. But you can see all this formula. ¿Pueden ver toda la fórmula de abajo? Que debe ser,
Sí,
que debe ser 36 más 108 más 72 igual 216. Si quieren la curiosidad, chequen en su calculadora y verán que sí les va a dar. ¿Ok? Here is another example. I had done this before in the other class and I forgot to erase. So, okay, it's better because I don't have to suffer writing this. It's very difficult for me to write on these words with the mouse. I have to get calligraphy lessons on the mouse. But for this circuit, the same questions obtain the total resistance. Okay, the current and voltage across each element. Total resistance is easy. 3 plus 1 plus 2 is 6 kilo ohms. Here we have 6 kilo ohms. Then obtain the current. Remember what we did? We have to divide the voltage source divided by the total resistance is 120 volts, which I omitted the letter B here, divided by 6K. I didn't put K ohms, but sometimes it is abbreviated like 6K, and the result is 20. Because we are using kilo ohms, the result will be in milliamperes, which is equal to 0.020 amperes. Okay, so this is the current flowing across all the circuit. So we can skip this. We could calculate the voltage across each resistor and then multiply this voltage times the current, and we will obtain the, the result. But it's easier if we have the current here. We will use we will use this formula. I didn't write it. Let me write it. I'll put it here. I square, yo le puse aquí I times, voy a poner una X, which are, I will change R1, R2, and I3. So I put it here because the current is 20 milliamperes, is 20 square times 3 kilo ohms here. 20 square is 400. So 400 times 3 is 1,200 milliwatts. Milliwatts because we are using kilo ohms and the current is milliamperes. Or power in the second resistor is just the same current to the square is 400 times 1 because it's 1 kilo ohm and it's 400 milliwatts. And for the third, I didn't make the calculation. Why? Because I know that for 1 kilo ohm is 400 milliwatts. For 2 kilo ohms, of course, we are going to have the double. So it is 800. And if I did this first, I could save also this calculation, just put 400 times 3, and we'll have the same result. Okay? So we will have now the summation of the power. Let me put it. B total. I don't want to write, I just want to make it by heart, in my memory, and put the result. 120 plus 100 plus 400, it will be 160. And 1,100 plus 400 is 1,600 plus 800, it will be 2,040. I think it's 2,400. ¿Está bien? 8 y 6, 14. 1400. Me hace que está mal la suma, ¿no? ¿Quién me ayuda a hacer esa suma? 1200 más 400 más 800. Dejé mi celular en otro lado. ¿Quién me ayuda? ¿Sí me están escuchando?
Sí, profe.
2400.
Yes. Yes,
¿Cuánto?
it's
¿Cuánto da?
2400.
Ok, entonces está bien, 2400. Está bien, ok. That's the dissipation. For now, I can find the power delivered by the source. By the source, we just multiply the voltage of the source, which is 120 volts, times the current is 20 milliamperes. Va a dar 120 por 2, exactamente. Right? And the question, how does the power delivered by the source compared to that delivered by the resistors is equal? The answer is they are equal. Okay? Well, let me stop sharing and I will continue to check the list for those who are late. Bueno.